This is Chapter 9, Section 1, problem number 57. And in this problem, we have an airplane that wants to travel due west and it's traveling at 300 miles per hour, but there is a wind that is blowing the airplane north at 30 miles per hour. So the airplane wants to go due west, but unfortunately there's wind that's blowing it north. So the question is, what direction should the airplane fly? If it tried to fly straight across, it wouldn't. It would actually get blown up here and end up in this direction, or end up at this location. And we want the airplane to be here. So we realize that the airplane needs to head farther south, and then what will happen is the wind will take care of the rest of it, because the wind will blow the plane up to the location that we want it to be at. And so we've got these two vectors. We have the airplane's vector of what it's going to fly, the wind, and it will end up with a result of due west. So we mark in our triangle that we now have from our vectors the information we know. We know that we have a 30 mile per hour for the magnitude, which means the length of that side of the triangle. And here we have a 300 magnitude, which is the length of this side of the triangle. Since the question is, what direction should it head, we're going to use bearings. And since we're going to use bearings, remember that we either start facing south or we face north. And in this case, we're down in the southern part, below the x-axis. So we're going to be starting by facing south and turning to the west. So it's this theta that we want to find out. And in this triangle, what we're able to figure out with using trig is this angle here, this beta. And that would be, the beta is linked by the opposite and the hypotenuse, which is sine. So the inverse sine will give us our beta. And if we take beta and subtract it from 90 degrees, we will get our theta. And so we end up with a theta of 84.26, which is going to go in here for our bearings. And so our answer is south 84.26 degrees west.